There is internet issue. Okay. The question is before we moving for the permutations and combinations, right? I have a question, right? So just imagine, right? From Colombo to Kandy, we have three different routes, right? So maybe you can use one of the routes to travel from Colombo to Kandy, right? Similarly, from Kandy to Ampara, we have two routes, right? Now, a person A wants to, maybe a person wants to travel from Colombo to Ampara, right? What are the different routes he can use to travel? How many possible options? Tell me. This is one type of question, right? After we learn the permutations and combinations, you need to answer these type of questions, right? So just imagine from Colombo to Kandy, we have three routes, right? Route one, it means one type, maybe there are three routes to travel from Colombo to Kandy. Similarly, from Kandy to Ampara, we have two routes, right? Now tell me, uh, what are the different ways, what are the different options to travel from Colombo to Kandy? What about others? Only few answering my question, right? If you understand my questions,
Six.
you can answer, right? Okay. In this subject, we will discuss these type of things, right? Practical things.
Six.
How many? How many possible options to travel from Colombo to Kandy? Similarly, from Kandy to Ampara, right? One guy, uh, he has a bike or a car, right? From his car, he need to travel from Colombo to Ampara, right? Maybe because of some reasons, right? Flood or some different reasons. Some roads maybe they will close, right? But they definitely they need to move to Ampara. So what are the different options they can? How many options? How many possible ways to travel from Colombo to Ampara based on this
Six
scenario?
ways.
Yeah, six. What about others? How we can find out six routes? Tell me. How you can find out six routes? So that just imagine, right? I number the roads, right? Maybe this is road 1, road 2. This is maybe road 3, right? This is, we can say, road 4. This is road 5, right? Just imagine. Now, can you write all the possible options to travel from Colombo to Ampara? Maybe some one guy, right? Maybe he can take from road 1 to road 4, right? Another guy, he can travel from road 1 to road 5, right? Another guy, he can pick the road 2, then he can road 4, right? Or road 2 to road 5, right? Similarly, road 3, then he can travel to road 4 or road 3 to road 5, right? So altogether, six options, right? So how you can find out? So to answer this question, right, you need to find out how many possible options from Colombo to Kandy. So there are three options, right? So 3 into, right here, there are two options, 3 into 2, 6, right? So just imagine the Sri Lankan map, right? We have different cities, right? They have different roads, right? If it is only two cities or three cities, we can just manually write the things and we can find out the answer, right? But not the case in real, right? Just imagine you have 5 to 10 cities, right? You need to travel between uh, these cities. You need to find out some efficient ways, right? Or you need to find out all the possible ways between the all the possible ways we need to find out the most efficient way to travel from a particular city A to B, right? So at that time we cannot manually write the things, right? We cannot write all the possible ways and we can't do that, right? So these type of questions, if you know the theories principles behind the permutations and combinations, you can easily answer the questions, right? So this is one example, right? Okay, I will tell another example, right? Before moving to the subject, I will tell another example, right? So here there are six different ways he can travel from Colombo to Ampara, right? Okay, now there is another question, right? Just imagine, right? Okay, you are preparing a, signal light or something, right? You are preparing a signal light, right? They have five colors, not the traditional signal road signal lights, right? This is something different, right? You are preparing a signal light, right? They have five colors, right? Maybe black color is there, right? Blue, black, black color, then red color is there, yellow color, green color, and orange, right? Altogether here we have five colors, right? So in the each color they have two types of signals, right? One is dark and one is uh, dim color, dim, right? One is dark, maybe dark blue or light blue, likewise, right? The another one is light in the sense very dim, right? So if you think about red color, maybe it's that signal blink dark color, dark red, as well as light color red. Each one has different meanings, right? Now tell me, by using this signal, what are the different signals you can pass to the pupil, right? So this is the question, right? You are creating a signal, right? Signal lights. They have five different colors, right? Five different colors. Each color they have two notations. Maybe if it is a dark light notate, dark light is on. They have some meaning, right? The light version is the dim color. Dim version is blinking. They have different meaning, right? Likewise, how many different signals you can pass to the pedestrian? So whatever where you are using the signal light, how many different signals you can uh, display to the pupil?
10.
Yeah,
10.
10. Yeah, what are they? Maybe if you indicate black color, maybe there are two options, right? Maybe dark or light, right? Just imagine here, if it is a black color, right? They have two options, right? Dark or light. Similarly, red color, they have dark or light, right? Yellow, two, dark or light, right? Likewise, we have 10 options, right? So it means by using this signal, you can uh, notate, you can display 10 signals to the pedestrian, or where we are using this type of signals, you can indicate 10 different types of instruction to the people who are observe these signals, right? So likewise, these type of questions, you need to know the theories behind permutations and combinations, right? If you understand the concept, then only you can answer these type of questions, right? There is nothing to remember and answer these questions. If you understand, then only you can apply the correct formulas and other things to answer the questions, right? That is important here. Okay. Yeah, the last example, I will tell another example. Okay. Just imagine there is a playground, right? Just imagine there is a Pallegala playground, right? Okay. If you understand, just answer my question, this question, right? Just imagine this is a ground, right? Here in this ground, we have different gates, right? Okay. Yeah, this is a ground, right? For this ground, there are gates, right? Here there is a gate one, here gate two, right? Here gate three, here gate four, here gate five. There are five gates for this ground, right? It means from different cities you can enter to the ground, right? Now, okay, one person, right, planning to uh, enter to this ground, right? The thing here, right? If a person enter by using one gate, he planning to outside. He planning to leave the ground by using another gate. right? Then tell me, what are the possible ways he can in and out from this ground? Did you understand my question? Let's imagine if a person enter by using a gate number 5, he cannot leave the ground by using the same gate. That is the condition here, right? If a person enter to the ground by using a gate 1, definitely he need to leave by using other gates, not the same gate, right? So if this type of question, how many possible ways that guy leave the ground, enter and leave the ground? Tell me. What are the possible ways a person enter and leave the ground? This is my question, right? Actual thing, if a person enter by using a gate, he cannot use the same gate to leave the ground. That is the condition here. Tell me. So how many ways he can enter and leave the ground? How you can answer this
20.
type of question? Sorry?
20.
Yeah, maybe give some correct answers, right? I'm asking you how many ways they can enter and leave the ground, right? How many? How many ways they can enter the ground and leave the ground? 8 is wrong, right? So if you look at here, maybe the person enter to the ground by using a gate 1, right? If a guy enter to the ground by using a gate 1, maybe he can leave by gate 2 or gate 3 or gate 4 or gate 5, right? So likewise, how many different possibilities a person enter and leave the ground?
16.
16 is wrong.
5.
20.
5 is wrong. So a better way, just you can write, right? Before you leave, before you learn these permutations and combinations, right? First of all, just you can try what are the possible ways. You need to manually write the things and check, right? Then after we learn the permutations and combinations, you can directly apply the principles behind the permutations and combinations, right? Now, okay, before apply some tricks, first I will show you. Just imagine a person enter by using a gate 1, right? Then what are the possible ways he can leave the ground? Maybe gate 2, gate 3, gate 4, or gate 5, right? So if a person enter by using a gate 1, he can leave gate 2. This is one way. This is another way. So altogether here, we have 4 options, right? If a person enter by using a gate 1, he have 4 options to leave, right? Maybe just imagine a person enter using a gate 2, then he can leave by using a gate 1 or gate 3 or gate 4 or gate 5, right? So here also he has 4 different options, right? So similarly, gate 3, if a person enter by using a gate 3, he can leave the ground by using gate 1 or gate 2, gate 4, gate 5. Here, 4 options. Similarly for gate 4, right? If a person enter by using a gate 4, he can leave by gate 1 or gate 2, gate 3 or gate 5. Here, altogether, 4 options, right? So if a person enter by using a gate 5, he can leave by using gate 1, gate 2, gate 3 or gate 4, right? So altogether, how many options? Tell me. 20 different ways a person enter and leave the ground, right? This is when if a person enter by using a gate, he cannot leave the same gate, right? Now tell me, there is no conditions like that, right? If a person enter by using the gate, he can leave. Maybe if he want, he can leave by using the same gate. Now tell me how many possibilities?
25.
25. Yeah, very good. 25. So these type of questions you need to answer. You need to understand the theories behind permutations and combinations, right? Why I tell some examples, then only you can eager to learn the subjects, right? So this is a very interesting subject, right? Not only here, there are so many places we can apply the theory to find out all the possible options, right? Maybe in the previous class, in the probability class, we discussed something called with card spec, right? You have a card spec, we need to take three cards. What are the possible ways you can pick the three cards? For that one, maybe you can apply the permutations and combinations, right? There are two different things, right? Permutation means we are giving priority for the order, right? That is permutation. Combinations in the sense we don't consider the order of we are taking, right? Only we need to take. Let's imagine as last class we discussed. You have a batch with 30 male students, right? 30 male students and 25 female students, right? I need to take 5 students randomly, right? To participate some events, right? Or just imagine I need to take 6 students, right? Three male students and 3 female students. I need to take to participate an event, right? So what are the different ways I can pick the students, right? How many different ways I can pick? How many possible ways I can pick? How you can find out the answer? Hmm? For these type of questions, can you tell me the answer? How many different ways you can pick these 3 students from 30 male and 25 female? But if you learn these permutations and combinations, you can understand, right? So here, this type of questions, there is no priority for the order, right? Which order we are taking, right? Here, uh, only the requirements, we need to pick 3 students, 3 male students and 3 female students, right? So these 3 male students, we need to pick from the 30 male students. 3 female students, we need to pick from the 25 female students, right? To Okay, the answer is now you cannot. Is it possible to tell me how many possible ways you can pick these students? Hmm? Tell me. Can you answer my questions? Is it possible to write all the possible ways and answer the question? Tell me.
16.
How many?
16.
Not 16. It's a huge number, right? Just imagine in your class 30 male students, right? If you take 3 male students, how many possible ways you can take 3 male students? Tell me. Is it 16? It's not possible, right? 30, not 3, right? 30 male students, right? Even if you divide it by 3 students, at least you are getting 10 groups, right? That is not the way. Just imagine maybe, okay, M1, M2, M3, M4, M5, right? Now just think about it will go until M30, right? So maybe you can take M1 plus M2 plus M3 together. They have, maybe you can take these 3, right? One option. Maybe another guy, he will take uh, M1, M2, M4, one group, right? Another guy, M1, M2, M5. Likewise, there are huge number of possible option to pick the students, right? So if you learn 3 to the power 30, it's not correct, right? So for that one, you need to learn the combinations, right? So there is something called, I will write the answer now, right? There is something called NCR, right? From n objects, you need to take r objects, right? In this scenario, r is less than or equal n, less than or equal n. It means the largest number is n. It means your population, right? This is your population, 30 students. From this 30 students, you need to take 3 students, right? This is r. So we can write, if it is an equation, n factorial over n minus r factorial into r factorial, right? So similarly, if I apply the same scenario here, 30C3, right? 30 factorial over 30 minus 3 factorial into 3 factorial, right? So if you calculate this one, the answer is 30 into 29 into 28 into 27 factorial over 3 factorial, 3 into 2, right? So this is a big number, right? Not only this one, right? Then multiple by 25C3, right? 25 factorial over 25 minus 3, 22 factorial into 3 factorial, right? The multiplication of this number and this number, we can say how many possible ways we can pick 6 students from the population of 30 male and 25 female students, right? So this is the subject we are planning to discuss, right? So counting means we need to find out what are the possible ways we can pick or get something, right? Okay, now we will move for the theoretical things, right? We will discuss a little bit later, right? Okay, now we will look at some basics, theories before we move for the permutations and combinations, right? So I think just you can clear, right? What are the things we are doing here, right? We need to find out possible ways, how many different options to pick something from a group of objects, right? That is what we are planning to discuss here, right? The difference between permutations and combination. Permutations means we give the priority for the order where we can select, right? Just imagine priority in the sense, just imagine you have a three students, right? Just imagine you have a three students, right? You need to pick two students, right? You have three students. You need to pick three. You have a three students. You need to pick two students. What are the possible ways you can pick based on this previous case? Uh, 3C2, right? 3 factorial over 3 minus 2, 1 factorial into 2 factorial, right? 3 into 2 factorial, 2 factorial will goes, right? Then 1. So three different ways we can select. Let's say we can say student 1, student 2, and student 3, right? Now can you write how you can pick? Maybe you can pick student 1 and student 2 as a group, right? Or you can pick student 1 and student 3 as a group, right? Or you can pick student 2 and 3 as a group. So these are the three different groups you can select, right? So this is called combinations, right? Here there is no order. Student 1 and student 2, one group, right? Permutation in the sense in which order you are picking, right? So S1, S2 is a different thing. S2, S1 is a different thing, right? So here you are picking student 1 as a first option, then you are picking student 2, right? But if it is a permutation, this is different, this is different, right? Similarly, here S3, S1 is different. Here S3, S2 is different, right? So if it is a permutation, right, from three students, you are picking two students, it has 6 ways, right? So the order of you are picking the students is different here, right? First you are picking student 1, then student 2 is picking here. But if you think about here, here you are picking second student first and you are picking student 1 as a second priority, right? So if you think about this one and this one different thing, that is we call permutation, right? So permutations mean you are giving more priority for the order you are picking, right? The arrangement of the things, right? But if it is a combination, just we need to pick a group of objects. We don't consider the priority of objects, right? So if it is a combination, these two are considered as the same, right? These two are considered as the same, right? But if it is a permutation, this is different, this is different, right? That is the thing you need to differentiate between permutations and combinations, right? Okay, now we will move for the theoretical things, right? This chapter develops some techniques for determining without direct enumerations. It means we cannot always write all the possibilities and find out the answers, right? That is not suitable all the scenarios, right? So some small group of objects, we can write all the possibilities and we will find out the answers what they are asking, right? But not the case if you have 100 or 50 objects, right? It's not possible to write all the possibilities, right? It takes half an hour more than that, right? So here, what we are planning to learn here, without enumeration, without counting the objects, by using the theories and some tricks, we will find out the number of possibilities for something, right? To arrange something, what are the different possibilities, we will find out, right? Okay, there are two basic counting principles, right? Sum rule principle, product rule principle, right? These are the very basic counting principle, right? So if you're counting something, you can apply two principles, right? One is addition of addition. Addition means you get the sum of the things. That is, we can call sum rule principle. The second one is multiplication, right? We can multiple something to find out, right? So addition and multiplication are the two counting principles in the mathematics, right? So we will look at what is sum principle and product principles, right? Sum in the sense additions, product in the sense multiplication principle, right? So the sum principles means, just imagine you have an event, right? We already learned the event in the probability, right? So there is an event. If you toss a dice, what are the possible events? 1 to 6. These are the sample space, right? If you get the even number, that is a one event, right? If you get the odd number, that is an event, right? Now they are telling similar events. Just imagine an event E, right? That event occur in M ways, right? So if you think about an event E, right? There's a sample space S, right? Uh, yeah, that sample space dice toss a dice, right? 1 to 6. So these are the sample space, right? The even E odd number, right? So what are the possible ways? 1, 3, 5, right? So how many ways the event occurs? Tell me. 3 ways even E occurs, right? So that is they are giving, maybe in this example they are giving, this is M ways, right? So here M is equal to 3, right? Now there is another event F, right? That event square number is 1 and 4 is the two square number, right? So this event occurs 2 times. So they are telling M times this event occurs, right? So N is equal to 2, M is equal to 3. It means how many times this event occurred, right? How many possible ways that event occurred. They are giving that two things, right? Now we need to find out, just imagine, yeah, better this, I will consider, there maybe F is an even number, right? So 2, 4, 6, right? Now this is also 3 ways it will occur, right? 2, 4, 6. So E is an odd number, F is an even number, right? Now they are giving both events E and B are not happen simultaneously. It means what? It means what? Simultaneously means they are disjoint, right? They are not happen concurrently, right? In this scenario, now we need to find out the occurrence of even E or F. So how we can find out? Just you can calculate the M plus N. This is the total number of possibilities that even E or F occurs, right? M plus N. If you get the sum of M plus N, so M means 3 times even E occurs, 3 possibilities to even E occurs. Similarly, 3 possibilities to even F occurs, right? So now we need to find out how many ways the even E or F occurs. So then you need to get the sum of these two, right? If it's a product principle in the sense, similarly, you have two events, E and F, right? So even E occurred M ways, right? Even F occurs N ways. Another thing, the even E and F are independent events, right? There is no depending on each others, right? So the probability of event E occurs not depending on the probability of event F occur, right? Similarly, the probability of event F occur not depending on the probability of event E, right? That's we can say they are independent events, right? So we are already discussed, right? Probability of A intersection B is equal to, if it is an independent event, what is the theory we discussed last class? If two events A and B are independent, then what is the probability of P of A intersection B? Tell me. Independent events in the sense it's opposite side of the conditions probability, right? So it means P of A intersection B is equal to P of A multiplied by P of B. Don't you remember those things? Tell me. We discussed last class, right? So at least tell me what is the theorem, conditions probability theorem? Okay. The conditions probability of A for the given event B already occurred. So how we can calculate probability of A intersection B over P of B, right? So from this we will calculate P of A intersection B is equal to, for this one, if it is an independent events, we can put P of A condition probability P of B is equal to P of A multiply P of B, right? I think we discussed those things last class, right? Just revise the theories, right? So now multiplication principle means the product principle in the sense you have two events, E and F. They are independent events, right? Now we need to find out the combination of E and F occurred, right? Just look at here, the combination of E and F occurred, right? So at the time you need to multiple the two element. M into N is the scenario we can find out, right? So if you look at an example, you can easily understand, right? So just look at the previous example, the Colombo to Ampara, right? So A, B, C. So here there are three routes, right? Here two routes, right? Now what will happen? A person move from Colombo to Ampara, right? So Ampara to Colombo, right? Okay, just think about this is K, right? This is Ampara, this is Colombo, this is Kandy, this is Colombo, right? A person move from Ampara to Colombo, right? From Ampara to Kandy, we have three routes, right? From Kandy to Colombo, we have two routes, right? Now, what did you do? You can find out all the possible options, three options here, two options. So we multiple 3 into 2, right? This is the product rule, right? We apply the product rule, okay? Because these two events are independent events, right? So, so here the event from Ampara to Kandy, they have three different possibilities. Similarly, for Kandy to Colombo, we have two different possibilities, right? So altogether 3 into 2, 6 possible ways we are moving from Ampara to Colombo, right? So yeah. So if it is a two events, this one, right? Now just imagine not only we can apply these sum rules and the product rule for only two events, right? Even if you have more than two events, you can apply the sum rule, right? Just think about you have a three events, right? Even E1, they have N1 occurrences. Even E2, they have N2 occurrences. Even E3, they have N3 occurrences, right? Then this, if you apply the sum rule, how many ways in the sense you can get the sum of N1 plus N2 plus N3, right? Even if you have more than two, you can get the sum of all the numbers, right? That is a sum rule. If you get uh, multiplication rule, product rule also for more than two events, right? N1 into N2 into N3 or more than that, right? So just think about it here. If you have another if you have another town, right? Here, just think about from Colombo to Goal, right? Colombo to Goal. Here we have three ways, right? Now tell me, then what will happen? Here, how many possible ways? 3 into 2 into 3. This is the possible number of ways we can pick a route, right? Altogether, 18 ways we will travel, right? So there is nothing, some rules in the sense, you can find out the sum of all the possibilities. Product rule in the sense, you can get the multiplication, right? Now we will look at this example, then you can easily understand what I am telling here, right? Now, just think about, just read this. Suppose a university or college, they offer three different history courses, right? They are offering three different history courses, right? Okay. In the history basket, they are offering three courses, right? Similarly, in the literature basket, they are offering four courses, right? In the sociology basket, they are offering two different courses, right? So maybe in the university or in a school, right? They have three different basket, right? In the history basket, they have three course modules, three courses. Similarly, in the literature basket, they have four courses. Similarly, in the sociology basket, they have two courses, right? Now we need to find out number of ways a student can choose one of each kind of course, right? What do you mean by uh, one of each kind of course? It means, right, here basket one, here basket two, here basket three, right? So maybe in your O level, you have three baskets, right? From each basket, you need to pick one subject, right? Let's say in basket one, you have three subjects. In basket two, you have four subjects. In basket three, you have two subjects. Now we need to find out what are all the possible ways you can pick these subjects. Just imagine your O level, right? You have six core subjects, three elective subjects, right? Each basket, we have different number of subjects they are offering. Different school, depending on their requirements, they are offering different subjects, right? Now, we need to find out one school, they have basket one with three subjects, basket two with four subjects, basket three with two subjects. Now, we need to pick uh, one subject from each basket. Now tell me, what are the all possible combination a student can take the subjects? How you can find out? So it means from each basket, you need to find out one subject, right? So now tell me for this type of questions, whether you can apply combinations or permutations. Combinations or permutations, tell me. So this is before we learn the combinations and permutations, we just directly apply the theories, right? The same theories before you learn the principles behind the permutations and combinations. Just with the knowledge we have, we can find out the answers, right? Now tell me whether it's considered as a permutations or combinations. What do you think? So a school offer three basket. Each basket you need to pick one subject. So how many possible ways you can pick these three subjects? How many possible ways? Okay, if I ask you to write here, we can say history subject H1, H2, H3, right? There are three subjects. Here L1, L2, L3, L4. These are the literature subjects, right? Here S1 and S2 sociology subjects, right? Now, if you don't know how to find out the answers, only solutions you have, right? You need to write all the possible ways, right? Maybe one way a student take H1, right? Then he take L1, then he take S1, right? Another guy, he can take H1, history subject 1, literature review 1, and S2, right? Another guy, he can take history 1, H1, L2, S1, H1, L2, S2, right? H1, L3, S1, right? Similarly, H1, L3, S2, right? Similarly, H1, L4, S1, H1, L4, S2, right? So maybe these are the options. You can pick the subject, right? Maybe one guy, he will take history 1, literature review 1, and sociology 1, right? Another guy, history 1, literature review 1, and sociology 2, right? So for H1, we have how many combinations? 2, 4, 6, 8 combinations, right? 8 different ways you can pick the subjects, right? Similarly, if you pick here H2, then you can write 8. Similarly, maybe here H2, L1, S1, right? H2, L1, S2, right? It will until we can have 8 options, right? Similarly, here, if you take H3, L1, S1, H3, L1, S2, right? Here 8. So altogether, 8 plus 8 plus 8, altogether, we have 24 options, right? So this is for this type of questions, you need to apply the combinations, right? Not permutation, right? There is no important for the order of the subject where you can pick, right? Only you need to think each basket, you need to take one subject, right? If you apply the theory of combinations here, what will happen? Here we need to take one subject from three subject, right? 3C1 multiple by four. So here you need to apply the multiplication rule. Why? You need to take each subject from each basket, right? So here 4C1 multiplied by 2C1, right? So we little bit later we will discuss what is NCR, right? 3C1 means 3 factorial over 3 minus 1 vectorial into 1 factorial, right? So 3 factorial, we can write 3 into 2 factorial over, I think you know factorial, right? N factorial means what? N into n minus 1 into n minus 2 until 3 into 2 into 1. We need to get the multiplication of 1 to n, that is factorial, right? So n factorial, we can write n into n minus 1 factorial. This is also correct, right? So if I apply the same scenario here, 3 into 2 factorial, uh, here 2 factorial, 2 factorial we can cut, 1 factorial is equal to 1. So 3 ways, right? So 3C1 is equal to 3. Similarly, 4C1 is equal to 4, right? Similarly, 2C1 is equal to 2, right? So altogether 3 into 4 into 2, 24, right? 24 different ways we can pick the subject for elective subject selections, right? So it means 24 ways people can take 3 subjects from 3 different pools, right? Any questions? Any questions? Okay, so this question says from each basket you need to take, each pool you need to take one subject, right? That is the requirement, that is a condition, right? So we can apply the multiplication rule, right? The product rule, then we can find out 3 into 4 into 2, then altogether 24, right? Okay, the second question, the number of ways a student choose at least just one subject from these courses. So how many ways you can select only one course from these uh, all subjects? So here what we need to do, from the pool 1 you need to take one subject. Also you need to take one subject from pool 2. Also you need to take another subject from pool 3. Then you can apply the multiplication rule. Right now the second question they are asking, you need to take only one subject from all these all these pools. Then yes, you can get the sum, right? So altogether you have how many subjects here? You need to pick one subject, right? So it means how many different possibilities you can take that subject. Maybe one guy take history 1, another guy take history 2, another guy take history 3, right? Maybe another guy take literature 1 or literature 2 or literature 3 or literature 4, right? Another guy, maybe he take sociology 1 or sociology 2, right? So these are the possible ways. So in this type of questions you can apply the sum principle, right? Not the multiplication principle. We can apply the sum principles, right? So if you apply the set theory, if you apply the set principles, right, we already know, right? So A union B means maybe either A or B. From all the events, you need to take only one, right? Just imagine here the event A, event B, or event C, right? So from these three events, you need to take at least one, right? Only one, right? So here number of A plus number of B plus number of C, right? This is A union, right? So if it is a product rule, right, that is a Cartesian product. Maybe you can learn those things in your sets and relations, right? Cartesian products, or maybe you can learn those things in your vectors, right? That is not here. Maybe you have another mathematics on that you can learn, right? So on that time you need to get the multiplication, right? Just you don't need to worry about these two, right? Just forget these two things, right? So yeah. Now we will move something related to factorials, right? I think you know what is factorial, right? Did you heard about factorials? Maybe you write a program in your C language, right, to calculate the factorials, right? If you use a input a value, you need to find out what is the factorial value of that one, right? Did you write the programs? Or did you heard about what is factorial? Oh, I already explained, right? Maybe in the previous class, I will explain, I think. Yes. So factorial means just understand, right? Okay, this is we can call n factorial, right? N factorial means you need to multiple. Here the n is an integer, right? The n is an integer value, right? There is no decimal or something, right? Only integers we can apply the factorials, right? So if it is a n factorial means you need to multiple the values from n to 1, right? So let's say from n into n minus 1 into n minus 2 into, it will goes until 5 into 4 into 3 into 2 into 1, right? Okay, now tell me 3 factorial means what? 3 factorial means 3 into 2 into 1, right? So from that number, you need to get the multiplication until 1, right? That is we can call factorial, right? So n factorial means we need to get the multiplication from 1 to n. That is we can call factorial, right? The important thing, this is integer. Also, this is a positive integer, right? There is no negative number. We can apply the factorial theorem, right? Only positive integers we can apply the factorials, right? So factorial means we need to multiple from 1 to n, right? So now tell me what is t factorial? T into t minus 1 into t minus 2 until we need to multiple 3 into 2 into 1, right? This is we can call t factorial, right? So just look at here. They are multiple by 1 into 2 into, there is not decimal, 1 into 2 into 3 into until n minus 2, n minus 1, n, right? This is factorial. Maybe from 1 to n you can multiple, or n to 1 you can multiple. Both are same, right? Let's say 3 factorial, you can write 3 into 2 into 1, or 1 into 2 into 2, 1 into 2 into 3. Both are correct, right? So the same answer, 1 into 2, 2 into 3, 6. 1 into 2, 2, 2 into 3, 6. Right? So both are correct, right? Okay. Another important thing you need to remember. Okay. Just think about, right? 10 factorial, right? How you can write 10 factorial? 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, right? Now tell me, if you look at these elements, what did you say? If you look at these elements, what did you say? Here, 1 into 9, we can multiple. Then what is this? If I multiple from 1 to 9, what is this? So here I write 10, right? So now tell me, if I multiple these values, what is this one? So 9 into 8 into 7 into 6 into 5 into 4 into 3 into 1. So now what is this? This is what? This is what factorial?
Factorial of 9.
9 factorial, right? So maybe I can write 10 factorial into 10 into 9 factorial, right? Depending on my requirements, I can write whatever the factorial, right? Maybe I can write 10 into 9 into 8 factorial, right? It means 10 into 9, then the remaining is 8 into 1 via multiple, right? Similarly here, 10 into 9 into 8 into 7 into 6 factorial. Up to my requirements, we can write the factorial in different ways, but all are same answers, right? So sometimes if you look at 5 factorial, right? Maybe I can direct, let's say, sometimes I have 5 factorial. I can directly write 5 into 4 factorial, right? Maybe sometimes I will write 5 into 4 into 3 factorial, right? All are, you can understand, right? So if I write this way, it explanation of 5 factorial in different ways, right? So just remember these things, right? Another thing, right? 1 factorial is equal to what? So 1, right? So only unit 1. 1 factorial is equal to 1. You need to remember, right? Also, not factorial is equal to 1. This is you need to remember, right? We cannot prove not factorial is equal to 1, right? Similarly, 1 factorial is equal to 1, right? Other things you can calculate, right? 3 factorial means 3 into 2 into 1, right? So it is equal to 6. 2 factorial means 2 into 1, 2. 1 factorial is equal to 1, right? Not factorial is equal to 1. You need to remember this one, right? This is you need to remember. Not factorial is equal to 1. So sometimes n factorial you can write n into n minus 1 factorial, right? Or maybe sometimes you can write n into n minus 1 into n minus 2 factorial. It's up to our requirements we can write, right? So these are the things you need to remember, right? Now, if it's a 3 factorial means you need to 3 factorial means you need to multiple from 3 to 1. 3 into 2 into 1. So it is equal to 6, right? 4 factorial means 4 into, maybe you can write 3 factorial, right? So 4 into 3 factorial, we already calculate that is 6, right? So 24, right? This is one way. Or another way, you can write 4 factorial, 4 into 3 into 2 into 1, right? 4 into 3 into 2 into 1, 12 into 2 into 1, so 24, right? 5 factorial means, sorry, here I forgot the 5 factorial, right? 5 factorial means 5 into 4 factorial, right? 5 into 4 factorial, I know 24, so altogether 120, right? So if you know some factorial, directly you can apply the values and you can find out the answers, right? So here I forgot to put that factorial, right? Just put the factorial here. Okay. Okay, now look at here. Look at this one, right? So now 12 into 11 into 10 divided by 3 into 2 into 1, right? 3 into 2 into 1, right? Now what I can do, right? Here 12, 11, 10, right? I think you already know if I do the same thing both side of the equation or bottom and top of my equation, there is nothing happen, right? Now what I do, right? Both side I can multiple the 9 factorial, right? Now what will happen? 3 into 2 into 1 into 9 factorial, right? Now for this one, what I can write? Tell me. So 9 factorial means 9 into 8 into, I will multiple 2 into 1, right? Until 1 to 9, I can get the multiplication. That is 9 factorial, right? 9 factorial into 10 into 11 into 12. For this one, I can replace with 12 factorial over 3 into 2 into 1, 3 factorial into 9 factorial, right? Up to our requirements, you can apply different tricks, right? So that's why I will show you these things, right? Okay, next we will look at binomial coefficients, right? So binomial coefficients in the sense, right? We can denote binomial coefficient this way, right? There is a number n here, there is a number r here, right? The important thing here, n is greater than or equal r, right? N is the largest number, r is the smallest number. At least some scenario, r and n are equal values, right? Maybe we can write this way or we can write this way, r less than or equal n, right? This is the condition for binomial coefficient, right? It means r and n are equal values or are always lesser value than the n, right? R is the smallest value compared with n, or R and n are equal values. These are the situation, right? So this is we can call binomial coefficient, right? So this one we can call binomial coefficient, right? So we can read this one NCR, right? So this is uh, this is we can call binomial coefficient. We can read this NCR, right? Here n are positive integers, right? Positive integers, right? That is important. We cannot apply for negative numbers. R and n values are positive integers. So these are the two conditions, right? That plus means that is a positive integers, right? Z is an integer, then Z plus means that is a positive integer, right? We can read this one NCR. So this NCR is equal to n factorial over n minus r factorial into r factorial. Just you need to remember this equation, right? So if you look at NCR, you need to write n factorial divided by n minus r factorial into r factorial. So this is, we can call this one, we can call binomial coefficient, right? So if you look at here, now tell me, right, 10CR, how you can write? 10CR, how you can write? Just try yourself. 10 factorial over 10 minus, okay, maybe 10C3, right? 10 minus 3 factorial into 3 factorial, right? Now we need to find out the answer, right? So 10 factorial over 10 minus 3, 7 factorial into 3 factorial, right? Now how we can write? So 10 factorial, top element 10 factorial, lower element 7 factorial, right? So now we can write 10 factorial, we can write 10 into 9 into 8 into 7 factorial divided by 7 factorial into 3 factorial. Now I can cut 7 factorial, 7 factorial. Right now I can write 10 into 9 into 8 divided by 3 factorial, 3 into 2 into 1. Right, 1 means I don't need. Right, then the answer is here 3, here 3, right, here 1, here 4. So here 3 into 4, 12 into 10, 120, right? So this is the answer for this one, right? So binomial coefficient means that's a constant. Coefficient means that's a constant, right? The number, the constant value, binomial coefficient, right? Maybe we can apply a plus b whole thing the power 2. We can find out the answer by using this binomial coefficient, right? We know the form a plus b whole thing squared, a squared plus 2ab plus b squared, right? So we can get this equation by applying binomial coefficient theorem, right? So I will little bit within 5 to 10 minutes, I will explain this one, right? Don't worry now, right? So now you need to remember binomial coefficient. We can write this way: n and r. N is the largest value, r is the smallest value. Maybe n and r are equal some scenarios, right? N and r always positive integers. You need to remember n and r values are positive integers. R less than or equal n. That is a condition. These are the two things you need to remember to apply binomial coefficient. N and r positive integers. Also n less than or equal r, right? Then we can read this one as a NCR, right? The NCR in the sense n factorial over n minus r factorial into r factorial, right? You need to remember. Definitely you need to remember this one. NCR mean n factorial over n minus r factorial into r factorial, right? Okay, just tell me ACB. ACB. ACB means A factorial over A minus B factorial into B factorial, right? Whatever the things, you can find out these, right? Also, different books, they will explain in different ways, right? So maybe NR, some books they are telling NCR, right? Oh, this is correct. Also, sometimes NCR. Always I am using this one, right? Maybe this one is correct, this one is correct, right? Sometimes some books they are using C, N, and R. This is also they will explain, right? So you don't need to remember this one and this one, right? Normally I am using this one, right, for NCR, right? Okay. So binomial coefficient means NCR, n factorial over n minus r factorial into r factorial, right? N factorial over n minus r factorial into r factorial. You need to remember this one, right? If it's a binomial coefficient, you need to remember this, right? Okay, another some important things, right? This is you need to remember, right? Okay. Rather than I'm using this form, I'm writing NC R is equal to NC n minus R. Both are correct, right? This is you need to remember, right? NCR is equal to. So this is they are explaining by using binomial symbol, binomial coefficient symbol. They are telling this one, right? So NCR means NCR, this one, NC n minus R. Both are equal values. It means the both have same values, right? How you can prove this one, whether it's both are correct or wrong? How you can check this, right? Just look at here, right? 10C. Yeah, I will try little bit slow, right? Yeah, okay. Someone tell, please little bit slow down, right? So binomial coefficient in the sense, we can denote binomial coefficients by using this symbol, right? So we can read this one as a NCR, right? Maybe you can write this way, NCR, or maybe sometimes you can write this way, right? NCR, right? Both are correct, right? So here, so if it is a NCR, you need to remember N and R are positive integers, right? N is the largest number, R is the smallest number, right? Sometimes N and R are equal, right? NCR, we can find out the value N factorial over N minus R factorial into R factorial. You need to remember this one if it is a NCR, right? It is, you need to know this one if you do the calculation with combinations, right? To do the combination related things, you need to apply this equation, right? Now they are giving NCR, the value of NCR is equal to the value of NCN minus R, right? It means, let's say we are look at with numbers, right? 10C3 is equal to what? Tell me, if I apply this theorem, this rule, what will come? 10C3 is equal to 10C3 is equal to 10C 10 minus 3. It means what? 10C3 is equal to 10C7, right? Now, can you find out the answers for these two? Can you find out the answers by applying the same equations? Can you apply? So the equation says NCR is equal to n factorial over n minus r factorial into r factorial, right? This is the equation. So now how I can write 10 factorial over 10 minus 3 factorial into 3 factorial. Here 10 factorial over 10 minus 7 factorial into 7 factorial, right? Here 10 factorial over 10 minus 3, 7 factorial multiple by 3 factorial. Here 10 factorial over 10 minus 7, 3 factorial into 7 factorial. Both are correct, right? Here 7 factorial into 3 factorial. Here 3 factorial into 7 factorial, right? Both are correct, right? So maybe why we are telling these, maybe sometimes you can easily replace these, right? Maybe if you know the value of 10C3, right? If you know the value of 10C3 is equal to something, right? Let's say 125,000 or likewise, right? Just imagine this is not the correct value, right? 10C3 is equal to this one. If I ask you what is the value of 10C7, then you don't need to do the apply the equation and write, right? So you can write 10C7 is equal to 10C 10 minus 7, right? By based on this theorem, based on this principle, we can say 10C7 is equal to 10 minus 7. 10C 10 minus 7, it is equal to, we can write 10C3, right? So already we know that 10C3 is equal to 1255. Then you can directly write the answers, right? You don't need to do again and again the same thing, right? So that's why we introduce some theories. NCR is equal to NCN minus R. So the behind theory is NCR is equal to NCN minus R, right? Both are correct, right? Okay, what do you mean by this one? So we can write NC naught, right? NC naught means n factorial over n minus naught factorial into naught factorial, right? Then we can write n factorial over n minus naught n, right? From n we subtract 0, that is n factorial into naught factorial. N factorial, n factorial, it will goes. Here the bottom is, the top is 1 is there, right? Bottom not factorial is equal to 1. So the answer is 1, right? So the answer is 1. Give me a minute. Sorry for that. So similarly here, here not C naught, right? Not factorial over not minus not not factorial into not factorial. That is 1, right? So just they are giving some example, right? Mhm. Okay. Okay. Now, can you find out the answer for this? So, if it is a 8 and 2, this is a binomial coefficient. You can write this one as a 8C2, right? So then you can write 8 factorial over 8 minus 2 factorial into 2 factorial, right? So 8 factorial over 6 factorial into 2 factorial, right? So 8 into 7 into 6 factorial. Here 6 factorial, we can cut both. 2 factorial is equal to 2. So here we can cut 2 and 8, 4. So 4 into 7, 28, right? Similarly, 9, the cofactor of 9 and 4, right? Then we can write 9C4, right? 9 factorial over 9 minus 4, 5 factorial into 4 factorial, right? 9 into 8 into 7 into 6 into 5 factorial. Then we can cut 5 factorial, right? Here 4 into 3 into 2, right? So we can cut this 8 and this 8, right? Here 3, here 2 is there, right? Then 9 into 7 into 2, right? 18 into 7, 18 into 7, 126, right? Similarly, you can practice for this one as well, right? So this is important, right? In the cofactor, binomial coefficient, right? The important thing here, right? So if I give you 10, 10 and 3, can you find out the equal cofactor, equal binomial uh, coefficient for this one? Hmm? Can you tell me the equal binomial coefficient for this one? Can you tell me the equal binomial coefficient for this one? 10C, this is equal to what? 10C3, right? So here how I can write? 10C, 10 minus 3, both are correct, right? So it means it is equal to 10C3 and 10C7 are same values, right? This is related to 10C3 is equal to 10C 10 minus 3, right? It is 10C7 and 10C3 have same values, right? That's they are explaining. Any questions? Hello, any questions? Any questions? Okay, now tell me, okay, 7 and 2, right? Can you find out the equal binomial coefficient for this one? Equal binomial coefficient? Tell me, anyone? Hello, did you understand or not? If you have any questions, let me know. Or you don't understand anything. Any questions?
No, sir.
So the equal value for this binomial coefficient is 7, 7 minus 2, 5, right? So it is equal to 7C2, right? It is equal to 7C, 7 minus 2, 7C, 7 minus 2, 7C5, right? So these are the equal values that they are explaining here, right? Yeah, very good. Okay, the last thing, Pascal triangle, right? By using this binomial coefficient, we can find out Pascal triangle, right? So Pascal triangle in the sense, yeah. Okay, now we will move for this binomial coefficient and Pascal triangle, right? I think we already know, right? A plus B whole thing to the power of 2. So what is the uh, how we can write A plus B whole thing to the power of 2? How we can write? Tell me. A squared plus 2AB plus B squared, right? Can you tell me A plus B whole thing to the power of 3? What is that? Hmm? What is the normal way you can do, right? You can write A plus B, then A plus B into A plus B, right? Now, A plus B you can write. For this A plus B into A plus B, you can write A squared plus 2AB plus B squared. Then you can remove the bracket by each element, right? So then you can A multiple by A squared plus 2AB plus B squared plus B into A squared plus 2AB plus B squared, right? Then what is the answer? A cube plus 2A squared B plus AB squared, right? Plus A squared B plus 2AB squared plus B cube, right? Then from all these elements, I can write A cube, right? 2AB A squared B plus A squared B 3a squared b plus 3ab squared plus b cube, right? So this is the answer for this one, right? So this is the way you can, normally you can find out the uh, long form of each equation, right? A plus b whole thing squared, quadratic equation, cubic equation, whatever the value. Now it's if it is a plus b cube, you need to do a lot, right? Now tell me, what about a plus b whole thing to the power of 7? It's too much of time you need to take to find out the answer for this, right? A plus b whole thing to the power of 7, right? But if we have some theorem, Pascal theorem, right? If we apply that theorem with within a few lines, within a one or two lines, you can find out the answer, right? For that one, we need binomial coefficient, right? So that equation says this one, right? This is the equation to find out whatever the values, right? The equation says, right? A plus b whole thing to the power of n. N may be whatever the value, maybe that must be a positive integer, right? N must be a positive integer. Maybe n may be 100 or n maybe 50 or 10 or 20, whatever the values. We can find out this form very easily for whatever the number here, right? So for this one, I think this is summation, right? We can call this one as a summation, right? So summation in the sense, summation of I is equal to 1 to 5. Here, I is there, right? So it means, summation means for I, this is the start value, right? This is the starting value of I. This is the in value. It means I take from 1 to 5, right? So now, if I write this way, the meaning of this one, I need to get the sum of all first 5 values. So if I write this one, this is we can call summation. Summation. Here we have I is there, start value 1, end value 5. Then we can write, now I take 1, right? 1 plus 2 plus 3 plus 4 plus 5. So this is the meaning of summation, right? So if I write summation here, right? So from this is the start value, I is equal to 1. This is the starting point. Then I take 5 is the last value. Then you can increase 1 by 1, right? Now tell me summation of, now I am telling I is equal to 1 to 5. Now I squared. Tell me what is the answer for this one? What is the answer for this one? Summation of I is equal to 1 to 5. Now I squared. So what is the answer for this one? 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, right? It means for I am taking 1, then I am taking 2, 3, 4, 5. So from this is the starting point, this is the end point, right? Now tell me summation of I is equal to 3 to 5 or 3 to 6. Then I, what is the answer for this one? So now what is the sum? Hmm? So I starting from 3, right? Then I can get 3 plus 4 plus 5 plus 6. So the answer is 3 plus 4, 7, 7 plus 5, 12, 12 plus 6, 18. So 18 is the answer for this one, right? I think you know this symbol, right? Now you can familiar with this symbol or not? I will explain again, right? So this is one symbol, right? Okay. Yeah. So why we are using the summation symbol, right? Let's imagine I need to get the sum of 1 to 100, right? So I need to get the sum of 1 to 100, right? 1 plus 2 plus 3 plus 4 plus 5 plus. So if I need to write 1 to 100, it takes huge time, right? 99 plus 100, right? So if I write this one, it takes huge time, right? So sometimes I need to get the square value of first 100, right? 1 squared plus 2 squared plus 3 squared plus 4 squared. So it will take huge time, 99 squared plus 100 squared, right? It takes huge time, right? To reduce this time consuming, right? They introduce a symbol, right? That symbol we can call summation, right? So if I write summation of I means, So I need to get the I n times, right? For that one, I need to define the starting value. So this here, I'm writing here, I is my starting value. Maybe starting value, whatever a number, maybe normally zero, starting from zero or one, right? Or one, whatever the number. Starting value, look at by here. So I am writing here 10, right? So it means for the previous example, so from this is starting value, this is in value, right? I need to get the sum of 1 plus 2 plus 3 plus 4 plus 99 plus 100, right? Rather than I'm writing these, it's a huge time taking scenario. I am replaced with this, right? If I write this one, it gives the same meaning of this one, right? So now tell me, I need to find out a cube plus uh, 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, 6 cube, 7 cube, 8 cube. Sorry, 7 cube, 8 cube, 9 cube, and 10 cube, right? How I even to write this one, I take huge time, right? Rather than I'm writing this one, how I can write by using the summation symbol? Can you try this one? How you can write the answer for this one? So rather than I am getting the sum of these values, directly I can write summation, right? Here maybe a cube or b cube or c cube. If I put a cube here, now I need to define the value for a. A is equal to 1. Here, what is the value? What is the value comes here? Tell me. So rather than I am writing a long uh, sentence or long summation or something, to simplify the things, to reduce the time, we are using this symbol, right? So a is equal to 1 to, what is the value comes here? Tell me. So rather than I am writing this one, if I use the summation symbol, what will come here? A is equal to 1 to, tell me. Yeah, 1 to 10, right? So here I need to write 1 to 10. So the meaning of this, I need to get, I need to assign 1 as an initial value for a cube, right? So for a cube, if I assign for a1 means that is a 1 cube, right? Similarly, then I need to assign the next value is a takes 2, right? So plus 2 cube. Then the next value it will take 3 cube, right? Similarly, it will take until the last value 10 cube, right? So rather than I am spending so huge time to write these within a single line, I can explain these, right? So to that easiness, we can write this one, right? Okay. Now I am writing, right, to A. Then what is the form? If you write the uh, large form, how you can write? Tell me what is the value it will come. What is the answer for these? A is equal to 1 to 10 to A. Then what will happen? First, you can assign 1 for the 2A, right? So now it will happen 2 into 1 plus, now you need to assign the value of 2 plus 2 into 3 plus 2 into 4 plus 2 into 5 plus 2 into 6 plus 2 into 7 plus 2 into 8 plus 2 into 9 plus 2 into 10, right? So now you need to get these values and you get the summation of these values, right? Even it's a huge time consuming task, right? To reduce that one, we can use the summation symbol, right? That's all. You don't need to worry about anything, right? If you look at something here, if you look at these type of things, the bottom element, we can say starting point, right? We can say this is the starting point. This is the last value it will takes. Last value it will takes. Between these, you can assign each whole number, right? Maybe here, if I starting from 5, what will happen? So you need to write 2 into 5 plus 2 into 6 plus 2 into 7 plus 2 into 8 plus 2 into 9 plus 2 into 10, right? You need to get the sum of these 5, right? So this is the starting point. This is the in value. Between that, you can apply each value for your equation, whatever you have, right? So that is the meaning of summation, right? Okay, why we need the summation? To find out the extracted form of any equation, right? A plus B whole thing to the power 2, only we know, right? Maybe some of you know A plus B whole thing to the power of 3 also, you know, right? Now, some situation happen, you need to find out A plus 3, A plus B whole thing to the power B, 2 and 3 we know, right? How about A plus B whole thing to the power of 5? It takes huge time, right? uh, Maybe you need to write a plus b, a plus b, a plus b 5 times, right? It's a huge work, right? To reduce this one, we can apply this binomial coefficient, right? So that is the equation where we stopped, right? So just look at here. So to find out this one, right, a plus b whole thing to the power n, now you just little bit understand what is summation, right? So I think you just little bit know what is summation, right? So a plus b whole thing to the power of n, right? For that one, you need to write in the summation form, right? Summation k is equal to 0. So here they are starting from 0, then the last value is n, right? Why I'm putting here n? So I need to find out a plus b whole thing to the power of n, right? I need to add a plus b whole thing to the power of n. For that one, I can replace by here. Now I need to write here NCR, right? NCK. So in this scenario, NCK, right? So NCK into means multiplication, a to the power n minus k into b to the power k, right? So from this equation, you can easily find out the extension of whatever the equation, right? So summation of k is equal to 0 to n, nck into a to the power n minus k into b to the power k, right? Okay, now tell me, okay, k is equal to 1 to 5 k, right? So how many times you can add, how many times you are doing addition? 1 plus 2 plus 3 plus 4 plus 5, right? So you are assigning 1 for k, then assigning 2 for k, 3 for k, 4 for k, 5 for k, right? 5 times, right? Yeah, very good. 5 times. Similarly, now if you remember this equation, by using this equation, whatever the formula a plus b whole thing to the power 10 or 20 or whatever, you can easily find out. So now I will show you how you can apply this equation for a plus b whole thing to the power of 2, right? So already you know the equation for this one, right? So what is the equation? A squared plus 2ab plus b squared, right? This is you already know, right? Each and everyone know a plus b whole thing to the power of 2 is equal to a squared plus 2ab plus b squared, right? Now we will find out this by using this binomial coefficient, right? How we can do? Now we can write this one a, okay, a plus b whole thing to the power of 2, it is equal to summation of k is equal to 0. Then what will come here? 2 is coming, right? 2ck, 2ck, k now what? K is 0 here, right? 2ck into a to the power 2 minus k into b to the power k, right? Now, what will happen? I will assign, now first I will assign k is equal to 0, right? So what is k is equal to, if I assign k is equal to 0 for this one, what will happen? If I assign k is equal to 0 for this one, what will happen? 2c 0 into a to the power 2 minus 0 into b to the power 0. Then I need to add a plus symbol, right? So now I take 0. Now again I can assign 1 for k. Now what will happen? 2c1 into a into 2c1 into a into 2 minus 1 into b1. Then plus, so k first take 0, second take 1, the last one k takes 2, right? So 0 to 2 means lastly it will take 2, right? So 2c2 a into 2 minus 2 into b to the power 2, right? Now if I find out all the values for this one, I know the equation, right? Now tell me what is the value for 2c0? We already know 2 factorial over 2 minus 0 factorial into 0 factorial, right? 2 factorial is equal to 2 into 1, 2, right? 2 minus 0, 2. 2 factorial, 2. 2 minus 0, 2. 2 factorial, 2. Not factorial is equal to 1, right? Now what is the answer? 2 over 2, 1, right? So the value of this one is what? 1, right? So 1 into a to the power 2 minus 0, 2. So a squared. So b to the power 0. If any base, if the power is 0, the value is equal to 1, right? So we already discussed in the first class, right? The index power is any base. If the power becomes 0, then the value is equal to 1, right? So by applying this one, so now b to the power 0 is equal to 1 plus, now tell me what is the value for 2z1? 2z1, it is equal to 2 factorial over 2 minus 1 vectorial. 2 minus 1 vectorial into 1 vectorial, right? 2 factorial 2, 2 minus 1, 1 vectorial 1. So 1 into 1, 1. So the answer is 2, right? So now this value becomes 2. 2 into here a to the power 2 minus 1, a to the power 1, right? Into b to the power 1, right? Plus 2c2. What is the value of 2c2? 2c2 is equal to 2c2 minus 2, right? It means what? 2c2 minus 2, 2c0. 2c0 already we find out. The value is 1, right? So then 1 into a to the power 0. A to the power 0 means a to the power 0. 2 minus 2, a to the power 0 into b square, right? Then the answer is 1 into 1, 1. So a square plus 2ab plus b square, right? So now we are getting the answer by applying binomial coefficient, right? Similarly, whatever the value, you can apply this theorem and find out the answer. That is, we can say is binomial principle, right? So that is we can call binomial principle, right? So similarly, if you need to know a plus b whole thing to the power of 3, just directly you can apply on that equation, right? So how you can apply? So you can apply summation of k is equal to 0 to 3, right? NCK into a to the power n minus k into b to the power k. Yeah, I will explain for this one, right? So now we need to find out the answer for a plus b, right? A plus b whole thing to the power of 3. The answer is a cube plus 3a squared b plus 3ab squared plus b cube, right? This is the answer we need to get, right? So this is, I remember this, I write, right? If you don't remember, just you can apply this theorem, right? So just nothing, right? Just you need to remember this theorem only, right? If you know this theorem, right? A plus b whole thing to the power of 2 to find out the longest form, right? K is equal to starting value 0 to n, right? N minus k. So here it means they are written in the form of binomial coefficient, right? So n k, we know it is equal to nck, right? That's why I'm writing in my equation this way, right? It's easy for you rather than I'm writing this way, n and k. If I write this way, you can easily understand. That's why I'm writing this n and k is equal to nck, right? So if I apply for a plus b whole thing to the cube, right? Now I can write, right? Now my first, the k takes 0, right? Now, so now the n value is what? N is 3, right? 3ck 3ck into a 3 minus k into b to the power k, right? Now, if I first I need to take 0 for k, right? Now, what will happen? 3c, for this k, I am putting 0. 3c, if I take k is equal to 0, 3c 0 into a to the power 3 minus 0. 3 minus 0 means 3 into b to the power 0, right? B to the power 0 means that is 1, right? So b to the power 0, b to the power 0 plus now my k takes 1, right? If I take 1 for k, 3c1 into a to the power 3 minus k. 3 minus, now k is 1, no? So 3 minus 1, 2 into k is 1, right? B to the power 1 plus 3c2. Now I'm taking 2 for k. Now I'm taking 2 for k. So 3c2 a into 3 minus 2, 3 minus 2. From 3 minus k is now 2, no? So 3 minus 2, 1. So b to the power 2 because k is equal to 2 now, right? Plus 3c3 because now I am taking 3 for k. That is my last point. K takes 0, 1, 2, 3. So 3c3 a to the power 3 minus 3 a to the power 0 into b to the power k. B to the power k. So k is equal to 3, b to the power 3. So the answer is 3c naught. 3c naught means that is 1, right? 3c naught is 1. If you need, you can find out. 3c naught means 3 factorial over 3 minus naught factorial into naught factorial, right? So 3 factorial over 3 factorial into naught factorial 1, right? So that is equal to 1. So here this value takes 1, right? I don't need to mention 1 here. So a cube b to the power 0 is equal to 1. So I omit that one also. B a cube plus 3 to the power 1 is equal to 3, right? 3 to the power 1. I know the value. If you need, you can find out. 3 to the power 1 is equal to 3, right? 3 factorial over 3 minus 1 factorial, 2 factorial into 1 factorial, right? 3 into 2 factorial, 2 factorial we can remove, right? So the answer is 3. 3 into, so this one is a 3, a squared b plus, I think you know, right? 3c2 is equal to 3c 3 minus 2, right? So it is equal to 3c2 is equal to 3c1. So 3c1 and 3c2 also have same value, right? So I can put 3 here. For this one, I am replaced with 3 a b squared plus 3c3. 3c3 is equal to what? 3c3, I can write 3c 3 minus 3. So 3c 0. So 3c 0, I already know. What is the value? 1. So here also it will come. 3c3 also take 1. So I can omit 1. 1 into a to the power 0 also 1. Then b cube, right? So I can omit now. So the answer is a cube plus 3 into a squared b plus 3 into ab squared plus b cube, right? Likewise, you can calculate whatever the value by applying this theorem, right? Also for your exams, right? If I ask you this type of questions, right? Definitely I will give the equation, right? Don't need to remember the equation, right? Just you can apply and give me, right? So if I ask, I will give this equation. So you can use that equation and find out the answer. Okay. Okay. If the binomial triangle means, right? So the binomial triangle means, right, this binomial coefficient. By using this binomial coefficient, we are creating, right? Just omit these elements, right? Binomial, to create binomial triangle, right? This is the equation, right? So summation of k is equal to 0 to n and k. Or maybe if it's confusing, you can write nc k, right? Now to find out the binomial triangle, this is binomial triangle, right? To find out binomial triangle, what you need to do, you can assign n is equal to 0, right? If I assign n is equal to 0, what is the value comes here? So here it 1 summation of, 0 summation of k is equal to 0 to 0. So 0 C 0. What is the value here? 0 C 0 means 0 factorial over 0 factorial into 0 factorial, right? So it is equal to 1, right? The first value becomes 1, right? Now I need to take n is equal to 1. Right? If I take n is equal to 1, right, what will happen? Summation of k is equal to 0 to 1, right? 1c 1c k 1c k, right? Now in this equation, 0 ck, likewise it will comes 1c k, right? 1c k means 1c k, right? 1c k means what will happen? Now I need to assign 0 for k. First time I need to assign 0 for k. 1c 0 plus 1c 1, right? So 1c 0 is equal to what? 1c 0, 1 factorial over 1 factorial into not factorial, right? So that is equal to 1. 1c 1 also 1, right? So now the second value becomes this way, right? Now again I need to assign n is equal to 2, right? If I assign n is equal to 2, k is equal to starting from 0 to 2, 2c k, right? Now what will happen? 2z0 plus 2z1 plus 2z2, right? 2z0 is equal to what? 1, right? 2z1 is equal to 2, right? 2z2 is equal to 1, right? The next value 1, 2, 1, right? Now if I take n is equal to 3, now if I take n is equal to 3, now what will happen? Summation of k is equal to 0 to 3. Here 3ck, right? Now first k take 0. If I take 0 for k, 3z0 plus if I take 1, 3z1 plus 3z2 plus 3z3. Now what is the value? 3z naught, 3z naught, 3 factorial over 3 factorial into naught factorial. It is equal to 1, right? So 3c naught 1 means 3c, 3c naught 1 means 3c 3 minus naught. So 3c3 also same, 3c naught and 3c3 also same value. So here this one also 1, right? Now if I consider this one 3c1, it is 3, right? 3c1 means 3 factorial over 3 minus 1, 2 factorial into 1 factorial. So 3 into 2 factorial over 2 factorial into 1 factorial. So we can cut this one and this one. So 3 is the answer, right? So if 3c1, just look at here. If 3c1 is equal to 3, we know 3c3 minus 1 also is equal to same, right? So 3c3 minus 1 means 3c2 also same, right? So 3c2 also 3. So in my triangle, now it will come 1, 3, 3, 1, right? Now if you look at here, can you tell me what is the next one? So this is a triangle way, right? 1 coming, then 1, 1, then it will happen. These two values are get the sum 1, 2, 1, right? Here 1, 1 plus 2, 3, 1, 2 plus 1, 3 here. What is the next value? Tell me. 1, 3 plus 1, 4, 3 plus 3, 6, 3 plus 1, 4, then 1, right? It will go continuously, right? So this is we can call Pascal triangle, right? So it will starting from 1, here 1, 1, here 1, 1 plus 1, 2, and 1, right? So the first and last elements you need always take 1, right? So for the, so now here n is equal to 0, here n is equal to 1, here n is equal to 0, n is equal to 2. Now tell me what is n is equal to 3. So first and last element consider as a 1, 1. Right now 1 plus 2 is equal to 3. Here 2 plus 1 is equal to 3, right? So now if you know these, now tell me what is n is equal to 4. So the first and last elements are 1. So 1 plus 3 is equal to 4. 3 plus 3 is equal to 6. 3 plus 1 is equal to 4. Now tell me what is n is equal to 5. 1, 1, right? 1 plus 4, 5. 4 plus 6, 10, 4 plus 6, 10, 4 plus 1, 5, right? Likewise, it will go. This is we can call Pascal triangle, right? So by using Pascal triangle, you can find out whatever the value of a plus b whole thing to the power of n, right? That is the benefit of this Pascal triangle, right? These are the basics, right, for the permutations and combinations, right? Now onwards we can move for the permutations, right?